Today we are going to continue with finding the sum of the terms in a geometric progression. Let's say we have a geometric progression, first term, second term, third term, and so on. And if you want to find the first nth term in the geometric progression, we can use this equation as n. What does it mean by that? Now let's say we want to find the sum from the first term till the ninth term. So that is, we want to find the first ninth term of this progression. We can use this equation. So here n is going to be 9. And this n here is 9. And then a, as usual, is the first term and r is the common ratio. This equation is used when the absolute value of r is greater than 1. And that means that when r is greater than 1, for example, 2, 3, 4, and so on. Or when r is less than negative 1, for example, negative 2.5, negative 6, and so on. If the absolute value of r is less than 1, then we are going to use this equation. R to the power of n minus 1 becomes 1 minus r to the power of n. Down here, also we swap the place. Now what does it mean by that? The absolute value of r is less than 1. This one is r is less than 1, but greater than negative 1. So for example, when r is 0.2, we use this equation. Or when r is negative 0.5, we use this equation. This time, I'm not going to derive the equation for you. Please refer to the textbook on how to derive these two equations. Let's do a few questions pertaining to these two equations. Find the sum of the first 6 terms of this geometric progression. Let's see what we know. A is 625. Then we find the common ratio. 25 over 125 is 1 over 5, or 0.2. R is less than 1. Since r is less than 1, we will use this equation. Next, we plug in the numbers. A is 625. And then r is 0.2. With the help of a calculator, we get 781.2. The sum of the first 6 terms of this geometric progression is 781.2. Find the sum of all the terms of this geometric progression. Let's write down the info that we are given. A is 0.2. Then we find the common ratio. 0.8 over 0.2 is 4. Since r is more than 1, we are going to use this equation. But we have a problem here. We do not know n. We are going to find the sum of this progression up to this 819.2. this term. We need to know 819.2 is which term. So we are going to write down Tn equal 819.2, and we want to find the n value. Tn is also ar to the power of n minus 1. And we plug in the number for a, 0.2. And also r, 4. Dividing both sides by 0.2, the right hand side becomes 4096. Right, we need to solve this equation to find n. We take log for both sides. And we move log 4 to the right hand side. With the help of a calculator, we get 6. So n is 7. This 819.2 is the 7th term of this progression. Now we can substitute all this number into this equation to find the sum of the first 7 terms. A is 0.2. We plug in this number. R is 4. N is 7. We plug in this number. And we get 1092.2.